good day to all. So we are here for our 4th week of online class for Essential Skills for Professionals 2, in which we basically talk about aptitude problems. Now when we talk about aptitude problems, particularly quantitative aptitude problems, of course we need to do arithmetic calculations in all types of problems whatever you get in a competitive exam. And now we all know that time is the main constraint in any competitive exam. Otherwise the standard of the problems are such that most of you, or rather all of you, can do all the problems, but the only constraint remains that time. So it's always our target that how we can speed up the calculations. And now today's class I have come with some techniques how you can speed up basic arithmetic calculations. Now whatever I'm going to tell, perhaps many of you know it, but maybe the main thing is that because nowadays we are mostly habituated in working with calculators, so we tend to forget the basic techniques which we all learn in school days. So that's why we just brush up some methods by which we can do basic arithmetic calculations in a much faster way. And even if we can save basically 2, 3, 4 seconds in a problem, then ultimately in a test of 50 problems it matters much, and it gains you the time to tackle still 2, 3 more problems. Now particularly those who have done some courses in abacus, Vedic maths, maybe you have gone through these tricks, these methods, whatever I will discuss, but at the same time I know that maybe all have not attended such courses. So I guess if you really go through this lecture, it will be helpful for you at the end to tackle any type of quantitative aptitude problems. Now whatever is the type of problem in a competitive exam, maybe it's just a simplification problem or a problem on profit and loss or simple compound interest, probability, ratio, proportion, whatever, time and work, what we did in the last class, definitely you cannot avoid arithmetic calculations. And what are the basic arithmetic operations? We all know that we have 4 basic arithmetic operations: addition, subtraction, multiplication and division. So today's lecture I will just talk about these basic operations. You may really think at the beginning that yes, why do we need this addition that we learn in our very childhood days, but yes, just to see that how we can minimize the time of doing a simple addition or a multiplication or a division and whatsoever. Okay, so let's get started. So the first arithmetic operation what I'm going to talk about is of course the addition, and the technique is called split and merge technique. So split, as you see the word split, the numbers which you are given to add, you just split them in some way. What way we are going to discuss? You split the digits in the number and then maybe you do the addition and then merge. So let us take an example. Now say I have an example over here, 1407 plus 892. Now first of all I have just shown the traditional method which anybody can definitely do it, but just to show that what happens in the traditional method. In the traditional method you just write the numbers one by one in rows and then you add. 7 plus 2 is 9, then 9 plus 0, like this you go on adding. Now what happens, you may say that what is there, it's very easy, why do we want to think something else? But the thing is that only just writing these numbers 1407 and 892, that itself will take 1 or 2 seconds. So the idea is, can we apply some other technique and we can do the addition mentally without wasting this 2-3 seconds of writing here and getting the answer. So what can we do? How can we do it mentally? as we have already told you that we will use the split and merge method. So what is done is basically I split the numbers as this also you used to do in your very childhood days, that split the numbers as per their positions in the thousands place, hundreds place, tens place, units place, like that. Now here 1407, here we have a thousands place, 892 doesn't have a thousands place, so even we can split the, we can forget the thousands place now, we can just split both the numbers in the hundreds place, tens place and units place and then merge, and we will get the answer. How? I have not written it because I just want that you should avoid paperwork and do it mentally. That's why I have not written the steps, I just explain. So what happens here is, if you forget the traditional method, just look into the numbers. Here I have 1400 and I have 800. So 14 and 8, 2200, so directly I get 22. And now if I look into the tens place, it's 0 plus 7, 9 and then 7 plus 2, 9. You just get the answer much more quickly instead of writing it here. Writing like this. So although it's a quite an easy addition, everybody can do it by the traditional method, but if you do it mentally like this, if you practice, you will see that definitely it will take less time than writing like the numbers like this, and then doing adding vertically will take more time. Okay, another example, 7877 plus 3966. So now we have to split both the numbers in the thousands, hundreds, tens and units places. So let us do it mentally. So it's 7000 and the next number is 3000. So total you have 10,000. Now if you go to the hundreds place, 800 and 900, so it makes you 1700. So 10,000 plus 1700 means 11,700. Mind it, 11,700. Now tens place, 70 plus 60, 130. So 700 plus 130, it's 830. So it's 11,830. And 7 plus 6 is 13. So 30 plus 13 is 43. So what's your total answer? 11,843. You can check with your calculator, you can check with your traditional method. This is the answer, 11,843. Okay, so as I told you that not that you get definitely a new answer, it's the same answer as you go with the traditional method, but 100% if you practice this, you will get the answer quicker than the traditional method. Maybe you save only 2, 3, 4 seconds, but that also helps much in a competitive exam. Okay, next we will continue with the split and merge method also, but sometimes we need not split all the digits in the different places, but we can think of in a different fashion also. So observe that 3966, actually if we can split it in a different way and just approximate it to the closest tens or hundreds or thousands, we may get answer quickly in some of the problems. So see that 3966, it's the closest to 1000 is 4000, so it's 4000 minus 34, right? So if we would have observed this, that 3966 is 4000 minus 34, then we can do it further quickly. 7877 plus 3966, that means I just directly add 4000, so it is 11,877 minus 34. So 77 minus 34 is 43, so we get the answer again 11,843. Okay, so this can be also an alternative procedure. Now which one to follow? Definitely you will learn with your experience. The more you practice, more you gain experience, and you know that which one can give you the answer more faster. Okay, so next with these two examples on addition, I will go over to subtraction. The method numbers in rows and then subtract vertically. What else we can do with the split and merge? Now split and merge again could have been by splitting the numbers in the thousand, hundred, tens and units place. But again that will become a bit longer. What else can I do? Can we do really? We have to think it intelligently that what else can be a process to get the answer quickly. Now one way, as I show it here, you see 3982. So 3982, this is 2893. Now if I split this 2893 more intelligently in a way that I have the same 82, then we can get the subtraction very easily. So what I have done here is 2882, and if I take 82, how far I am from 93? It's 11. So 2882 plus 11. Now 3982 minus 2882, so last two digits are 0, and 39 minus 28 is 1100. So 1100 minus 11, 1089. Now see, I have written all this for your understanding, but actually I will want you to do this problem without writing on pen and paper. Do everything what I explained mentally. It's 3982, so let us take here 2882. So if I'm taking 2882, how much I'm short? It's 11. So if I subtract 2882, it's 1100 minus 11. So you get the answer 1089. I can surely say that this is much quicker than if you would have written down the numbers one by one in the traditional method and subtracted it as the usual procedure. Okay, next answer, next question is 789 minus 699. Any guess how will you do? This is further easy. 6, I have not even written the clue over here. I can just tell you in a second, because 699, you know, it's close to 700, so make in 700. So 789 by minus 700, we can tell in seconds it's 89, but we have taken one more, so I have to now add that. So it is, your answer will be 90. So you have to think that which splitting can give you the answer in a much quicker fashion. Okay, so that's it. Now let us go for multiplication, which is the most important one, and it's difficult also. If you have a 2-digit, 3-digit, particularly 3-digit multiplication, it's more difficult in the sense it's more time consuming. So we need really faster techniques for the multiplication, much more that's demanded than the addition and subtraction. Now multiplication, we will discuss various techniques. The first one for multiplication again will be split and merge. So let us come to that. Let us come to an example, 16 into 23. Now split and merge, as you have already understood by this time, that we will split either one number or both the numbers and try to do something. Now split and merge in multiplication, I will not ask you to split in the units, tens, hundreds places and then do. That will become again cumbersome. But what we can do in this kind of problems, that you split one of the numbers, not both simultaneously, one of the numbers to its nearest tens or hundreds or whatever, and then do it. Like see, 16, we can easily visualize it's 20 minus 4. So 20 minus 4 into 23. 23 into 2, we know 46, so it's 460. Minus 23 into 4, we know it's 92. So you subtract, you get 368. Once again, I repeat, this line has been written here just for your first understanding. We will want you to do this, get this answer without writing this on pen and paper. You can do it mentally. Now, we could have tried the other way around also. Sometimes both are equally expensive, or sometimes one is easier than the other. So if we think of in the other way round, let us do it mentally now. 16 into 23, that I can write as 20 plus 3. Now 20 into 16, 2 into 16, we know it's 32, so it's 320 plus 3 into 16 is 48. 48. So 320 plus 48 is 368. See how quickly you get the answer. But if in a traditional method you would have written 16 below 23, then you multiply first with 3, then with 2, and then you add, it will definitely cost you much more time than these methods. Okay, I hope it's clear. So this OR I have also written here, but definitely avoid these steps. Do it mentally. Now another method, a plus b multiplied with a minus b method, or rather I can say it's a square minus b square method. Now many a times we get such questions like, say for example, instead of 16 into 23, if I would have had 16 into 24, what do you see? 16 is 20 minus 4 and 23 is 20 plus 4. So doesn't it fit to a minus b into a plus b? So you can further get the answer in a shorter amount of time if you have this. So it's 400 minus 16, it's 384. Now of course that this method applies to a very special class of problems, not all. But if you can observe that your multiplication fits into this a square minus b square formula, you can get the answer very quickly. Say another example, 706 into 694. Now if you would have written 706 multiplied with 694, you need now 3 intermediate steps in the traditional method. Once you multiply carried forward basically. So 6 sevens are 42, it's 2, and here comes is 4. Now if you read the second state, cross multiply the digits in the units and tens place and then add up. So units and tens place, so now it is 7 into 7, that means 49, plus 36. 49 plus 36, it's how much? It's 85, right? And now this 85 with this 4 which we had kept here for carrying over, that has to be added, so this gives you 89. Now 9 stays here and 8 goes down again, which has to be carried over.
89 plus 9, so it is now 98. Yes, right. So it is here 8 we keep, and this is here 9 we keep here for carrying forward. And now the last step, multiply both the digits in the hundreds place. So 63 and 9 is 72. So your total answer is 728280. You can check with a calculator or with a traditional method. This is going to be your answer. So it is a 5-step method, as I have written the steps over here. But if you practice, because you are just getting the answer in one line instead of writing so many rows, it will definitely save your time. So I repeat once more this one because it is a bit complicated than the previous one. So what we have done is, first multiply the digits in the units place, then cross multiply the digits in the tens and the units place. So it was like 5 into 5 and 2 into 6. Next, third step is cross multiply the units and the hundreds place. So 9 into 5 plus 7 into 14 plus the digits in the tens place. So 5 into 6, that is the third one. Fourth step is cross multiply tens and the hundreds. So 9 into 6 plus 5 into 7. And finally multiply the digits in the hundreds place. And every time you remember that we keep only one digit and the second digit is written down for carrying forward in the next step.
Okay, so for our better understanding, let us see one more example where we have to follow all the 5 steps as we had already mentioned here. Maybe we look quickly into the steps once again. Multiply both the digits in the units place, then cross multiply units and tens place and add up, then cross multiply units and hundreds place and multiply the digits in the tens place and then add up, cross multiply the digits and in the tens and hundreds place and add up, multiply both the digits in the hundreds place. So let us see this second example with all the steps. So first step, it's 9 into 4, 36. So it's 6 over here and 3 is kept down for carrying forward. Second step, multiplying the tens and the units place. So it's 7 nines are 36 plus 4 twos are 8. So 36 plus 8 makes it 44. 44 plus 3 I'm sorry, extremely sorry. It's 7 nines are 63 plus 8, so it's 71. 71 plus 3, it's 74. So it's 4 here and 7 is kept down. And now here in the third step, we are in the third step now. So 9 fours are 36 plus 6 fours are 24. So it's 60. 60 plus 7 into 2, 14. So it is 74. 74, and now you have to take a 7 here down, so it's 81. So we keep 1 here and 8 comes down. Now we are in the fourth step where we multiply the tens and the hundreds place numbers. So 7 6 are 42 plus 4 2s are 8, so it's 50. 50 and 8, 58. So I keep 8 over here, 5 comes down, and the last step, the multiplying the hundreds place digits. So 24 plus 5, it's 29. So it's 29298146. This is your answer. If you practice, I know you need a lot of practice for this, but if you practice, it is guaranteed that this will take less time than the multiplication in the traditional way. Okay, now the next thing, see, we have seen the methods for multiplying 2-digit number with 2 digits, then it's 3-digit with 3-digit. Now what happens if you have a 3-digit number and a 2-digit number? Can we apply the method? Yes, we can apply the same method. Only thing is that, so we come to the next case, multiplication of any 3-digit number with a 2-digit number. The same method is applied. Only thing is that the 2-digit number, you make it 3-digit by putting a 0 in its hundreds place. say 865 into 94, we will follow the same method, the same 5 steps, but with putting a 0 in the hundreds place. But actually it reduces to a 4-step method, not really 5-step, because you can guess why. In the 5th step we multiply the numbers in the digits in the hundreds place, and that is 0. So therefore it actually stops in the 4th step. Okay, so let us see it quickly how it goes. So 5 into 4, 20, so it's 0 over here and 2 kept down. Next is the units and the tens place, so it's 9 into 5, 45 plus 24, so it's 69 with a 2 added, 71, so it's 1 and 7 comes down. Next is our this excise step, so it's 8 into 4, 32, this is 0, 5 into 0, so we have only 32 plus 9 6 are 54, so it's 54 plus 32, that means 86. Now I had a 7 down for carrying forward, so 86 plus 7 is 93, so we have here 93, so 3 is taken, 9 kept down. Now the 4th step, 9 8s are 72 and this is a 0, so 72 and 9 makes 81. Now normally what we have done, we would have done in the 3-digit with 3-digit multiplication, you keep here 1 and put this 8 down. We can still do that now, see, but see that we don't need to do it and we directly can put the 81 here, because if you would have tried for the next step, this would give you 8 into 0, whatever you have here into 0 will give you a 0, so then whatever is kept here for carried forward, that should come. So therefore we can directly avoid the 4th step, and when here in the 5th step, and when we are here in the 4th step, we can just directly write here this 81. What we keep here for carrying forward, that will be the answer here also. Okay, so I hope I am clear. If you have any other doubts regarding this method, we can take it up in the discussion session. Maybe in the discussion session I will give you some numbers to play with, some numbers, and apply this method and then tell me the answer by using this type of methods for multiplication, and see that how quickly you can do it. Okay, now we have spent a lot of time on multiplication. The last basic arithmetic operation left is division, so we will do it quickly. Once again, it's just the split and merge technique as we have seen in addition subtraction. But yes, we don't need to split as per their units, tens or hundreds or whatsoever positions, but we split it as per our convenience. Let us see an example and then I will explain how we do it. So suppose the first example is 459 divided by 6. Now what we do is we split the dividend 459 into 2 parts, and the parts should be such that at least one of them should be divisible by this divisor. That is the technique here in division, that you split the dividend into 2 parts in such a way that at least one part is divisible by the divisor. So see, 459 divided by 6. So 459, what is a number which is close to 459 and divisible by 6? See, 45. If I just look into 45 also, we know that 6 7s are 42, 6 8s will go beyond 48. So what we can do is we can split 459 as 420 plus the rest, that means 39. So I just write it as 420 plus 39 by 6. So this we can get a quick answer. 6 7s are 42, we already know it's 70. Now what about 39? We again need to actually split this 39 again. So 39 again, multiple of 6 close to 39 will be 36. So it's 36 plus 3. Now 36 by 6, sorry, this is a 6 rather, 36 by 6, you will get a 6. And now what is left with? all the steps purposefully because we are supposed to do this mentally. So 36 plus 3, so 3 by 6 is half or 0.5. So finally you get the answer 76.5. So instead of writing the entire number and try to divide by 6, if we can just visualize and separate or split the number like this, we may get the answer in a shorter amount of time. Another example and last example for today. So it's 777 divided by 13. So now let us look into the 13th table and also look into 77. So 13, yes, which one will be closer to 777? See, 13 Sixer is 780, but it's little bit higher. That is also not a problem. So we can write 777 is 780 minus 3. So 780 by 13, that's 6. 6 minus 3 by 13. Now you should say, yes, this is a problem now, but yes, 3 by 13, that we can do it quickly. That division we can try to do it quickly, and if we can try to do it, it's 0.30, so 0.226. So you can just do it mentally also, it is 0.23. Now you should say that it is an approximation, not a right answer. But yes, most of the time approximation works, and when we have a large number of digits in the decimal place, usually most approximations we go for 2 decimal places. So this is quite a good answer, that up to 2 decimal places at 6 minus 0.23, it comes to 5.77. And if you use your calculator and look into it, I have checked, you will see that you will get it 5.697, something like this. So 769, something like this. So which actually when you approximate to 2 digits, it comes as 5.77. And even if you still compromise, still quicker we can get an answer if we can still compromise on the digits in the decimal place. Please see 3 by 13, it is closer to 3 by 12. If I approximate 13 by 12, so this becomes 1/4. So therefore 6 minus 1/4 means 0.25. So it's a further approximate number which can be obtained more quickly, is 5.75. But this is basically not really, I should say, approximate. Yes, it's approximate to 2-digit place, but it's correct up to 2-digit place, what we can tell. Okay, so we have seen a lot of techniques how to speed up your basic arithmetic calculations. We will stop here. If you have any doubts with these methods, please pose your questions in the live session, which is to start just after this. And otherwise, I will give you some multiplication, division problems to work out with these methods during that time. Okay, so goodbye for